Hello, and welcome to the Trepid Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. In this video, we will cover Domain 2.2 Cloud Computing Concepts. The cloud is a technology solution that has taken over and is here to stay. The cloud has many benefits for the enterprise and continues to enable businesses to be more agile and cost-effective in delivering business solutions. Because the cloud is in almost every enterprise now, it is essential as cybersecurity professionals that we understand the fundamental concepts of the cloud so we can understand how to secure it. The first thing we're going to talk about is the different cloud service models. So there are 3 different cloud service models the Security Plus exam wants you to know about. And these are typically the big 3 that are talked about. So the first one we have is IaaS, or Infrastructure as a Service. Infrastructure as a Service provides the user a bare metal server. This server's hardware is going to be maintained and controlled by the cloud service provider, but the operating system, software, and applications built on this server are the responsibility of the cloud customer. Infrastructure as a Service simply provides the server for your IT professionals to build on. This includes the OS and applications that you'll have to build. So really all infrastructure as a service is an easy way to spin up real servers, right? A real server sitting in a data center. But instead of you incurring the power costs, the maintenance costs, the HVAC costs, you just have a bare metal server sitting out in the cloud somewhere in an AWS region or zone, or Google Cloud, or Azure, whatever your flavor is. These bare metal servers, as far as a security perspective, you are responsible for them. So the cloud provider is not responsible for the operating system or the tech part of securing. The only thing they're responsible for is their data centers staying online, and there's no break-ins, which the break-ins usually don't happen. If they have happened, I'm not aware of any. The next one we're going to talk about is PaaS, Platform as a Service. Platform as a Service provides a platform pre-built for developers or IT operations to deploy code and applications rapidly without the burden of configuring the back-end databases or operating systems. So let's say you need to spin up a SQL database quickly for an application your enterprise has deployed. You can use Platform as a Service, where that cloud service provider will give you the compute, the storage, with an operating system already installed that's ready to do SQL database functions. And the last one we're going to talk about is SaaS, Software as a Service. This one is very common, and you use it every day without even realizing it. Software as a Service is complete integration in fully managed applications delivered to your enterprise from the cloud service provider. A great example is this that you may use in your daily life is a Google suite of tools, Google Drive, Gmail. That's software as a service. Amazon or AWS or all cloud service providers, they will also deliver applications to your enterprise like Office 365, right? So that's also an example of software as a service. Now let's move on to the different deployment models. Now that we've gone over the service models, right? The service models, we got to go over the different deployment models. So let's dive into this. The public cloud is the shared infrastructure between all tenants in the cloud. In a public cloud deployment, everyone's data runs across multiple servers in the cloud's data center. The public cloud is typically what you will see when you begin to integrate the cloud into your on-premise infrastructure. The public cloud offers data segregation or separation. The public cloud does not offer data segregation or separation, meaning that you can put firewall rules on your data. You can do microsegmentation, your own deployments, but truly, you're sharing all the resources with other tenants in the cloud, right? And the 3 biggest cloud service providers we have on here are going to be AWS Amazon, Microsoft Azure, and Google Cloud Platform. And again, this is the most common because its service model is cost effective, it's scalable, and it really is simple. I use the cloud for my labs when I do GNS3 labs. It's so easy just to spin up a VM and you don't do any of the maintenance costs, and it's on a uh, CapEx model, meaning if I only use that service for 12 hours in a month, I spent $3 and they maintained all the power and server for me, right? So the public cloud is a great thing. The next thing we're going to talk about is a private cloud deployment. A private cloud deployment is a pre-built infrastructure that a single tenant will only use. This deployment model offers the consumer the most privacy because your data is not distributed among different servers that house other organizations' data. So if you're looking for privacy and you're willing to spend, or let's say you're a government agency, you're going to go with a private cloud deployment model. You still get all the same functions as a cloud. You still get platform, infrastructure, and software as a service. But now you're not sharing your resources of all those tenants. And then we have a hybrid cloud. A hybrid cloud deployment can be any cloud model that gets combined, right? So if you're combining private and public, if you're combining community and public, it can also describe an on-premise and off-premise cloud deployment on the enterprise. So let's say you have Microsoft Active Directory and you want to move some of your domain services off to the cloud while also maintaining your infrastructure on-premise. That is considered a hybrid cloud deployment. The other cloud deployment model we're going to talk about is a community cloud. A community cloud is shared between organizations with similar goals and work in the same industry. Typical example of this is colleges doing shared research together on a project, so there is no intellectual property rights or nothing like that. They'll pool together their finances, really, their money, to deploy a community cloud for their infrastructure. So it's kind of like almost a private cloud, but for multiple different people, right? So two universities, let's say Harvard and Stanford, they're working on some real brainy tech solution, right? And they need to run their servers. They need a private solution, but not separated from the partner university. They can do a community cloud deployment. And then we have the cloud service providers. So there are many different cloud service providers. How you choose which CSP to go with depends on your organizational needs and which CSP can best accomplish business goals for your organization. So here's our top 10 cloud providers. AWS, as of this recording, dominating the market. Azure not far behind, and then Google Cloud. And then we have our other cloud service providers down here. All right, now getting into managed services. So managed services are IT companies that supply outsourced IT work for organizations without the need or the money for internal IT staff or structure. Sometimes an organization can only outsource parts of their IT infrastructure to cut costs or to be more efficient with their resources. So sometimes you'll still have your IT staff, but you may outsource some functions, right? And that'll save you money and cost. An MSP provides managed IT services, while an MSSP provides managed cybersecurity services. So MSP being managed service provider, MSSP being managed security service provider. Then we have our example here. So a mom and pop bakery, their needs have skyrocketed. They're not IT guys. They can't hire an IT person. So they go to their local MSP in the area. MSP is going to write up a business partnership agreement, an SLA for their services. And now that MSP and bakery enter into a contract for managed IT services. And now the MSP now has a team of IT or security professionals to maintain and manage the bakery's IT systems. Edge computing is a concept that describes putting more data processing devices with more computing and storage resources at remote sites that do not have a strong internet backbone. So imagine we have a plant way out in the sticks, right? Because that's where cheap land is. Well, there may not be a strong internet services out there for all the data processing they do in the cloud. So we can put edge devices that have those compute and storage resources in the factory to do a lot of our processing instead of using that bottlenecked internet connection. And then we have our different virtualization strategies. So virtualization has been the go-to solution for organizations in the past decade to best utilize their resources, really even beyond the past decade. There are different types of virtualization out there. And as far as using virtual machines, there's two different type of hypervisors we use. There's a type 1 hypervisor, and that's going to utilize the resources the best in virtualization because it's going to install a virtualization software on a bare metal server. That hypervisor software will then be configured to distribute resources among multiple virtual machines. So let's talk about this type 1 deployment. So essentially what you're going to have is a bare metal server with all of its compute and storage resources, and you're going to install that hypervisor engine like ESXi provided by VMware. And then you're going to use, let's say, like a web-based dashboard like VMware vSphere Client to manage that hypervisor to deploy multiple guest VMs or virtual machines. So there is no host OS on a type 1 hypervisor. It's just that hypervisor engine. And then you have a type 2 hypervisor. It's not as efficient as type 1, and it's typically not used for enterprise level deployments. This is going to be software that's installed on a host OS, like VirtualBox, right? Or VMware Player. And then that hypervisor application will run the guest VMs on top of that host operating system. And then we have a new kid on the block, which it isn't too new now. You know, we're talking July 15th, 2022 at the time of this recording. Containers are software packages containing all the necessary elements to run in any environment. Now, what do we mean by this? So containers or containerization allow developers and IT operations to deploy and provision applications in record time. An example of a container engine is something like Docker, which gets installed on the host OS, and then that container engine can run multiple different applications with all the necessary libraries and dependencies in that container engine, making the rapid deployment of applications viable for your enterprise. And then we have some security considerations for virtualization, like VM sprawl and VM escape. So VM sprawl is when VM deployment grows out of control and you no longer have the manpower, compute resources to handle the amount of VMs in operation. VM escape is when a user can access the hypervisor inside the VM, escaping their virtualized environment. And then another virtualization concept we have is a thin client. Thin clients are a part of a virtual desktop infrastructure that allows enterprises to offload their endpoint computing devices to a central server on the LAN or a SaaS provider over the internet. So all a thin client is just a piece of hardware with maybe like a flash, right? No hard drive that connects to a server that's going to deliver a VM as the desktop experience. So how does this help us in security, right? Well, versioning. If we only have to make sure these VMs are updated, this can help us offload a lot of that patching and management to all of our end devices. Because as long as we have one good VM that we can keep cloning that these users can use, our version control becomes a lot easier. And we don't have to worry about replacing legacy devices anymore, right? Because we can just always replace the virtual machine. Then we have another concept for virtualization called infrastructure as a code. So infrastructure as code is a DevOps concept that looks at your entire enterprise infrastructure as a piece of code that can be codified and managed from a central point of provisioning. So in this example, I have an Ansible server here that we're using to codify our network devices to give it a standard baseline, right? So one Ansible server looks at the network holistically and views that individual routers as just a part of one code base and uses that infrastructure as a code methodology to configure and provision network services, or really routers and switches across the country or across your enterprise. Then the last thing we're going to talk about is SDN. Software defined networking is a new concept that breaks away from traditional networking, where an administrator deploys, manages, and configures network devices from individual CLI sessions. Software defined networking decouples the control and data plane in a network environment and uses a centralized server for all routing policies, security policies, and version control. So something that I know about, right, is Cisco's flavor of this. That's DNA Center or SD-WAN. That essentially just, for the fundamentals, right, this isn't a CCNP class, takes a centralized server like that DNA Center. And that DNA Center is now the brains for our northbound and southbound controllers. Or rather, this is the controller that controls the southbound and northbound network resources. And it's going to do all the routing policies for all of our routers and switches down here. And then northbound, you're going to have your control console that connects that DNA center and controls the routing and security of your entire enterprise. All right. So that is it for Domain 2, Cloud Computing Concepts. I want you to join us for our next video, where we'll be covering Domain 2.3, Application Development, Deployment, and Automation. Thank you for viewing.